Liquid metal, room temperature. Physics broken. Silver poison, ancient mystery. One metal refuses to stay solid at room temperature. Its name is mercury. It pours like water. Every other metal stays rigid until you torch it. Mercury melts at -38 °C. That's colder than most winter nights outside. Scientists didn't fully explain this until Einstein's relativity showed up. Yes, relativity, the physics behind black holes and GPS. In 2013, physicists simulated Mercury without relativistic effects. Its melting point jumped to 82 degrees Celsius. That proves Einstein secretly shapes your thermometer. Ancient emperors drank this metal chasing immortality. China's first emperor swallowed mercury pills seeking eternal life. It killed him slowly while he searched for immortality. Alchemists called mercury the spirit metal of change. By the end, you'll know exactly why it stays liquid. You'll learn why gold and cesium almost break this rule. You'll see electrons moving near the speed of light. You'll understand how this metal poisoned entire villages. You'll discover why old thermometers used this silver liquid. This isn't a lecture, it's a 300-year mystery. Every fact here comes from real experiments, not myths. Stick around, the ending connects Mercury to superconductors. One element quietly rewired the entire periodic table's logic. Nothing about Mercury behaves like your chemistry class taught. Let's answer the question chemists avoided for 2 centuries. Metals are usually solid because their atoms share a sea of electrons. This electron sea glues atoms together into a rigid, packed lattice. That strong glue is why iron and copper stay solid at room temperature. Mercury has 80 protons, one of the heaviest common atoms around. Its electrons orbit so fast they approach the speed of light. At that speed, relativity kicks in and changes electron behavior completely. Fast-moving electrons effectively gain extra mass, according to Einstein's equations. That extra mass shrinks Mercury's outer 6s electron orbital dramatically. This shrinking pulls those electrons closer, tighter around the nucleus. Tightly held electrons don't easily join the shared metallic electron sea. Without that shared electron sea, metallic bonding becomes incredibly weak. Weak bonding means atoms barely hold on to their neighbors. Mercury atoms behave almost like they're avoiding each other entirely. This is called the inert pair effect in advanced chemistry. Mercury's electron configuration mimics a noble gas's filled outer shell. Noble gases like neon barely bond with anything at all. Mercury isn't a noble gas, but it borrows that same reluctance. Chemists call this a pseudo-noble gas configuration, rare among metals. Compare Mercury to cadmium sitting directly above it on the table. Cadmium has almost identical structure, yet stays solid until 321 degrees Celsius. The only real difference is Mercury's heavier, more relativistic nucleus. That one difference is enough to melt an entire metal structure. Gold sits near Mercury and shows this same relativistic fingerprint. Gold's yellow color comes from relativistic electrons absorbing blue light. Without relativity, gold would look silvery white, like ordinary metals. So relativity doesn't just melt metals, it colors them too. In 2013, chemists tested this theory with direct computer simulations. Researchers built a virtual mercury atom without relativistic effects included. That fictional, non-relativistic mercury had a melting point of 82 degrees Celsius. Adding relativity back dropped the predicted point to -23 degrees Celsius. Real mercury melts even lower, at -38.83 degrees Celsius exactly. Relativity alone explains a 105-degree swing in melting point. That gap proves Mercury's liquid state isn't ordinary chemistry, it's physics. This study was published in Anguante Chemi, a respected chemistry journal. It settled a debate chemists had argued about for nearly a century. Before this, textbooks blamed vague weak bonding without real explanation. Now we know exactly which forces are responsible, down to electrons. Mercury still conducts electricity well, despite its reluctant, shy electrons. That's because delocalized electrons still exist, just far fewer than usual. Fewer shared electrons mean weaker bonds, not zero electrical conductivity. This is why Mercury conducts but never hardens like typical metals. Mercury's density is also unusually high, at 13.6 grams per milliliter. That's why steel objects float on liquid mercury without sinking. Even a bowling ball would float on a pool of mercury. Density and liquidity together make mercury feel almost alien to touch. Every property traces back to those tightly bound, relativistic electrons. Chemistry textbooks rarely mention relativity, yet it's hiding in plain sight. Mercury is proof that atoms don't follow simple, classical physics rules. The heavier the atom, the stranger and more relativistic its behavior. Mercury was chemistry's first clue that relativity touches everyday matter. Mercury isn't chemistry's only near-liquid metal, just its most famous one. Gallium melts at 29.76 degrees Celsius, literally inside your closed palm. Hold a gallium spoon, and it liquefies within a minute. Cesium melts at 28.5 degrees Celsius, barely above average room temperature. On a warm summer day, cesium could technically turn liquid. Rubidium melts near 39 degrees Celsius, close to human body temperature. Francium likely melts near room temperature too, but nobody's tested it. Francium is so radioactive it decays within minutes of forming. Scientists have never gathered enough francium to see it melt. A synthetic superheavy element, copernicium, may also stay liquid. Element 112 has relativistic effects even stronger than Mercury's own. Physicists predict copernicium could boil near normal room temperature. That would make it behave almost like a heavy, metallic noble gas. So Mercury's strange behavior might repeat itself further down the table. One non-metal, bromine, is also liquid at room temperature. But bromine is a reddish halogen, not a true metal. That makes Mercury genuinely one of a kind among the metals. Mercury's name comes from the fast-moving Roman god, Mercury. Its symbol Hg comes from Greek words meaning liquid silver. Ancient civilizations already knew Mercury flowed differently than other metals. Romans used mercury to extract gold from crushed ore. That process, called amalgamation, is still used in mining today. Amalgamation dissolves gold into mercury, then burns the mercury away. Burning off mercury releases toxic vapor into the surrounding air. Artisanal gold miners still poison themselves this way today. In 1643, Torricelli filled a glass tube with liquid mercury. He flipped it upside down into a mercury-filled dish. The mercury dropped slightly, leaving empty space at the top. That empty space became history's first deliberately created vacuum. Torricelli had just invented the barometer, measuring air pressure. Mercury's weight made it perfect for measuring subtle pressure changes. By 1714, Fahrenheit used mercury to build reliable thermometers. Mercury expands evenly with heat, unlike unpredictable alcohol columns. That consistency made mercury thermometers the gold standard for centuries. Mercury also has unusually strong surface tension for a liquid. Its atoms cling to each other far more than to glass. That's why spilled mercury forms perfect, rolling silver beads. It refuses to wet or stick to most surfaces at all. In 1911, Mercury helped physicist Onnes make a shocking discovery. He cooled mercury down to nearly absolute zero, 4.2 Kelvin. At that temperature, Mercury's electrical resistance completely vanished. Electricity flowed through it with zero energy loss whatsoever. Onnes had just discovered superconductivity, using Mercury as his test subject. That discovery eventually led to MRI machines and maglev trains. One liquid metal quietly launched an entire field of physics. 19th century hatmakers used mercury vapor to soften animal fur. Breathing that vapor daily caused tremors, hallucinations, and confusion. That's the real origin of the phrase "mad as a hatter." Mercury poisoned people long before anyone understood the reason why. Mercury's usefulness came with a hidden global cost over centuries. Coal power plants are now the largest mercury polluters worldwide. Burning coal releases mercury vapor straight into the atmosphere. That vapor can travel thousands of miles before settling down. Mercury has been found in Arctic snow far from any factory. Wind currents carry it globally, ignoring national borders entirely. It eventually settles into oceans, lakes, and river sediments. Bacteria and water convert mercury into methylmercury, a deadlier form. Methylmercury climbs the food chain, concentrating in larger predator fish. That's why tuna and swordfish carry mercury health warnings today. Pregnant women are specifically warned to limit these fish. Developing fetal brains are extremely vulnerable to methylmercury exposure. In 2013, the UN created the Minamata Convention on Mercury. It's named directly after Japan's poisoned bay from decades earlier. Over 140 countries agreed to slash global mercury pollution together. The treaty pushed to phase out new mercury mines by 2032. It also phased out mercury thermometers across most of the world. Hospitals now mostly use digital or alcohol-based thermometers instead. Old mercury thermostats are being replaced in homes worldwide. Fluorescent light bulbs still contain tiny amounts of mercury vapor. That's why broken CFL bulbs require careful, specific cleanup. Dental fillings called amalgam still contain roughly 50% mercury. Amalgam fillings are considered safe once fully hardened and sealed. Many countries are still slowly phasing amalgam fillings out anyway. Chemists haven't abandoned liquid metals, they've just gotten safer. Gallium-based alloys now replace mercury in many modern devices. Gallinstin, a gallium-indium tin blend, stays liquid and isn't toxic. It's used in medical thermometers as mercury's direct replacement. Researchers now use liquid gallium in flexible, stretchable electronics. These circuits can bend, stretch, and even self-heal when cut. Liquid metal robots made from gallium can squeeze through tight gaps. Some prototypes can even merge, split, and reform like living cells. Scientists call this emerging field soft, liquid metal robotics. It sounds like science fiction, but it's active laboratory research. Mercury indirectly inspired this entire new branch of materials science. Ironically, its toxicity pushed chemistry towards safer liquid alternatives. Mercury still survives in a few specialized scientific instruments today. Electrochemists use mercury drop electrodes for extremely sensitive measurements. The calomel reference electrode still relies on mercury compounds. These uses are tightly controlled, monitored, and increasingly rare. Mercury taught chemistry a permanent lesson about invisible silent danger. A substance can look harmless while poisoning slowly over years. That lesson now shapes how new materials get safety tested. Every new liquid metal today gets checked against Mercury's toxic legacy. Mercury remains banned from most consumer products across the globe, yet it's still mined and used in small-scale gold mining. Millions of miners still risk mercury poisoning for a paycheck. The element that fascinated alchemists now demands careful, global regulation. Mercury's story shows how curiosity and danger can share one element. What started as ancient magic ended as a hard chemistry lesson. One element, countless mysteries, real chemistry, real danger, real wonder. Mercury isn't magic, it's relativity, disguised as liquid metal. Einstein's physics quietly explains something you can hold in your hand. Every silver bead of Mercury hides bent, relativistic electron orbitals. This single element launched superconductors, barometers, and modern gold mining. It also poisoned emperors, hat makers, and entire coastal communities. Now safer gallium alloys carry Mercury's legacy into new technology. Liquid metal robots today owe their existence to Mercury's mistakes. Chemistry isn't just formulas, it's stories hiding inside every element. Mercury proves the periodic table still holds genuine, unsolved mysteries. If this surprised you, imagine what gold's color is hiding. That relativistic effect doesn't stop with Mercury, it colors gold too. Which element should we investigate like this next time? Drop your guess in the comments before the next video drops. Subscribe if you want real chemistry, not recycled textbook definitions. This channel digs into the why, not just the what. Hit the bell so you don't miss the next deep dive. Share this with anyone who thinks chemistry class was boring. Mercury waited 3 centuries for science to explain it properly. Somewhere, another obvious fact is hiding an unsolved scientific mystery. Chemistry rewards curiosity. Mercury is living, liquid proof of that. Thanks for sticking around through 300 years of scientific detective work. Next time you see Mercury, you'll see relativity, not just metal. Comment one word, relativity, if your mind just changed completely. See you in the next investigation. Same channel, new mystery. Stay curious, stay skeptical, and never trust obvious chemistry again.